Okay, final section in this short unit is going to talk about solving systems of equations algebraically. So here we're going to use our two main tools, which will be substitution and elimination. So I'll walk you through both. You should have probably already seen both, but in case you forgot, I'll jog your memory. So remember, basically, if you followed along, in 8.1, we graphed solutions. You can always do this, but how do you do this algebraically? Okay. So we're going to do two questions and a problem. Let me just walk you through substitution, for instance. Substitution means if you have given this, say, these are two linear equations, so this is probably what you did in Math 10. Basically, you're going to isolate one variable, then substitute. Okay, then you're going to substitute. And what that means is here I isolated y. Okay, see, I isolated y equals 2x minus 5. That's from the first question. Then I substituted 2x minus 5 in for y into the second equation. What this does is now everything's in terms of x, therefore you can solve it. You can't solve equations that have two unknown variables. You can only do that with one, but if you write one equation in terms of one variable, then you can simply solve this, which will give you x. Then once you have x, you can plug this into either or equation. It looks like I plugged it into the first equation, so that went into here. Then I solve for y. Pretty straightforward. Elimination, which is my preferred method, typically. I'll use both depending on the situation, but I tend to use elimination more. Is when you try to remove or essentially make one term disappear. So for instance, if you look at these guys, if you're to add these together, okay, the product here would be 6x plus y equals 12. But let's suppose you multiply this whole first term by 2 first. That would give you 4x minus 2y equals 10. Then you would have 4x plus 2y equals 7. So take a look. That cancels when you add them, and you're left with 8x equals 17, so x equals 17 over 8. So very quickly we just arrived at this first result, right? Then you can go back in and substitute to get your y again. So this is a very fast method. That's basically it. That's what you spent 2 weeks doing in Math 10. Both of those methods, okay? Maybe not 2 weeks, maybe a week. We're going to apply that to solving linear and quadratic equations, which will be the first example you can see. So take a look at the, I would really like you to take a look at example 1 closely. Okay, so if you're using these videos for everything, please take a look and walk them through, because I actually solve it using both methods, using substitution and using elimination. Okay. When I do the practice problem, I'm going to probably use elimination. So let's take a look. Solve the following system of equations algebraically. 3x plus y equals negative 9. 4x squared minus x plus y equals negative 9. Okay, so right away you can make a decision what you want to use. I prefer elimination, and I'm going to try to eliminate. Which term do you think? Y. Has to be y, actually, because you're never going to get rid of this x squared, which means you're never going to have everything in terms of y. So we're going to eliminate y by multiplying the top term by negative 1. So if you multiply the top term by negative 1, that will give you negative 3x minus y equals 9. The bottom term is 4x squared if I write them all above each other. Look at this. Here, y's cancel. These guys also cancel to give you 0. So the result here of this addition is 4x squared minus 4x equals 0. And let's solve this. Okay, we can solve this right away. We can eliminate the 4's by dividing everything by 4. Okay, that will eliminate all the 4's. You're going to be left with x squared minus x equals 0. Then you're going to be left with x minus 1 equals 0, x equals 0, or x equals 1. Now you're going to have 4 points here, or 2 points, sorry, because now you have to resubstitute. So now you're going to resubstitute. Okay, x equals 0 into the equation. So for x equals 0, what is y? Well, y is going to equal 9, right? 3 times 0 plus y equals negative 9, sorry. Y is equal to negative 9. Therefore, 1 point is going to be 0 and negative 9. Then for x equals 1, I'm going to use the same guy right here. It doesn't matter what equation you use. It has to give you the same result. Here y is going to equal negative 12. Therefore your point would be 1 and negative 12. So now, I mean, that's it. Basically it. Solve the system. Well, here are the two solutions. You have to check if these solutions actually satisfy the system. Okay, so to check, and you can do a lot of this doesn't have to be written down. Okay, the first equation right here, if we call this equation 1 and we call this equation 2. Okay, for 1, I mean, look, if you plug in 0 and negative 9, you're clearly gonna get this first one's gonna work out very easily. You look at the second one, you type in 0 for x, you're gonna have 4 times 0 squared minus 0 plus negative 9 equals negative 9. Right, these guys all die, they turn into zeros, so this will be negative 9 equals negative 9. Check mark, that works out well. Okay, for the next point, we have 1 and 12. So by the way, that was for this. For 1 and 12, you plug in 3 times 1 minus 12 equals negative 9. That works out well. Right, so these checks are fast. These are fast checks, as long as your equation's pretty easy. You look at this, this is 4 minus 1, that's 3, minus 12 equals negative 9, that's negative 9 equals negative 9. That checks out to be true. So these are the solutions. Now you can check this graphically as well. Right? You could check this graphically. Plug them both in and look at the intersection. You're going to see a graph, and you're going to see one line that will pass through negative 9, and it'll be negative, so the slope will be negative, so it'll be something like this. Okay, and then you're going to have a quadratic that will open downward and will also pass through negative 9. So I don't know, something like this. Okay, that could be wrong, but you have two solutions, 2 points of intersection. Okay. So let's move on. Now we're going to model in a situation. These are good questions. Take a look at the example. It's very, very similar to the question I'm going to do. Here's the question I'm going to do. Determine 2 integers. These are like puzzles. Quite fun. Determine 2 integers that have the following relationships. 14 more than twice the first integer gives the second integer. The second integer increased by 1 is the square of the first integer. Write a system of equations that relates to the problem. Okay, part A. Great fun. So part A, what are we going to do here? Well, first of all, look, let's let first integer be x, okay? Let second integer equal y. that implies that the first term here, I'll say it, determine two integers, following relationship, 14 more than twice the finisher gives the second integer. 14 more than twice the first, okay? So 2 times x is twice the first, 14 more is plus 14, gives y, the second integer. Now the second integer increased by 1 is the square of the first integer. So the second integer increased by 1, y plus 1, is the square of the first integer, x squared. So there you have it. I mean, we rewrite this. We're going to have 2x minus y plus 14 equals 0. We can rewrite everything in terms of 0. Second one will be x squared. Be negative x squared, actually, plus y plus 1 equals 0. So there you have it. Okay. Let's solve that. That's what b is. That's what b is. Okay, right away you can do elimination. What can you eliminate? Eliminate y immediately. Because we have negative y here, and we have positive y. So if we add these two, right away we're going to be left with negative x squared plus 2x. Y's will cancel out, and you're going to be left with plus 15 equals 0. Divide everything by negative to make this a positive x squared term. And this is what you're left with. Okay? You factor this, so you're going to be left with x. Looks like it's going to factor quite nicely. 5 and 3. Negative 5 plus 3. X equals 5. Or x equals negative 3. Now, they asked for an integer, so these should both work, right? Let's check them. Make sure we did this correctly. Check. Well, let's see. 2 times 5 minus negative 3 plus 14. Does it equal 0? That's the question. So we have 10 plus 3 plus 14. Oh my goodness. Oh my goodness. And massive errors. Massive error. I'm plugging two x values into x and y, which is a big mistake. So don't make that mistake. Okay, that was a poor decision. Okay, this guy and this guy will give two different y values. So for here, if you plug in 5 in for x, you're going to have y equaling, and let me just show my work. I'm doing the first equation, so it's going to be 2 times 5 minus y plus 14 equals 0. This implies that y equals, let's see, 10 plus 14. Bring that over to the other side. Divided by that gives you 24. Okay. And this other solution, negative 3, will be 2 times negative 3 minus y plus 14 equals 0. So y equals, this one will give you negative 6 plus 14. Bring it to the other side, that's negative 8. But then you have that negative, so it's going to be 8. So the 2 points I'll write over here are 5 and 24. And let's see, negative 3 and 8. Okay, now we check, so sorry about that. But whenever you're getting no solution, you have to be very wary. Okay, you have to be very wary. Make sure you're looking at everything. Good thing I caught that, because this is going to be 10 minus 24, which is negative 14, plus 14 equals 0. 0 equals 0. There we go. First point checks out to be correct. Unfortunately, we got to check it for each and individual equation. Check it for the next one. We're going to have 5, negative 5 squared, plus 24, plus 1 equals 0. That's negative. This is interesting. That will be negative 25. Be careful there. That's going to be 0 equals 0 once again. So this first point is correct. Looking at the next one, here we go. 2 times negative 3 minus 8 plus 14 equals 0. What do we get here? This is going to be negative 14 minus 14. There we go again. Game, set, and match. Last one. Got to be careful here. But here we get negative 9 plus 8 plus 1 is 0 equals 0. All of them check out. That's a big check mark at the end. And there we go. Another big check mark at the end. So hopefully that makes sense to you. Right? Once you get the equation, everything else follows suit. So let's do one last example. Quadratic to quadratic. Okay, really no change at all. No change at all. Something I should highlight though is that, of course, when you're factoring, for instance here, at this step you can use the quadratic formula. I factored using guess and check, or not really a guess, really. You just, once you factor these a lot, you can see the solution. But if you can't see the solution, quadratic formula might be a good option. So let's take a look at the last practice problem of this chapter. Solve the following system of equations: 6x squared minus x minus y equals negative 1, and then you have 4x squared minus 4x minus y equals negative 6. Here you have no choice but to, if you're going to use elimination, you have no choice but to eliminate y. Eliminate y. And very simple to eliminate y. How will we do it? Let's change the sign of the second equation. Let's put all of these guys with a negative. I chose the second because I want to have a positive x squared term to start off. So for part A, let's do this in red. If we make that negative, then we're going to have 6x squared minus x minus y equals negative 1. And on the bottom, you're going to have minus 4x squared plus 4x plus y equals 6. The y's will cancel, and what you're going to be left with is 2x squared plus 3x equals 5. Now you rearrange, or you place this guy over here, and you look if this is factorable. Can we factor this? Well, let's try. I mean, the quadratic formula is a long procedure. It will give us a solution, but whenever you can, give this a whirl. And the only factors really that can do this will be 5 and 1, 2 and 1, so there we go. We have 2, and this will certainly factor. Okay, I did this guess and check. I taught guess and check quite a while back. You can use the quadratic formula. It's going to give you the same result. Here, x equals, and we just check this, negative. Okay, so that's 2x squared. I'm just checking my solution here. 2, 5. Yep. This gives us negative 5 over 2. X equals 1. Okay? So now we're going to get our y values, right? For x equals 1, actually let's do x equals negative 5 over 2, which by the way is of course negative 2.5. That might be a bit easier to plug in. We simply will plug it into, let's do the first one. We're going to have 6, 2.5, negative 2.5 squared, minus negative 2.5, minus y equals negative 1. Therefore, what we're going to be left with here, from the first terms together will give you 40 minus y equals negative 1, which will imply that negative 1 equals negative 41, so y equals 41. Okay? And then for the second, for x equals 1, we're going to have 6 times 1 squared minus 1 minus y equals negative 1, which will give you 6 minus 1 is 5. So you're going to have 5 minus y equals negative 1. And then you're going to have negative y equals negative 6, y equals 6. Okay? So far so good. So our 2 points will be negative 5 over 2 and 41 and 1 and 6. So like any good student, good mathematician, you're going to check your solution here. So, first equation, let's check. 6 times negative 2.5 squared minus negative 2.5, okay, minus 41 equals negative 1. True or false? True or false? Well, let's see. Negative 2.5 all squared times 6 plus 2.5 minus 41. So this is something you can just plug in, fire into your calculator. It definitely works. We have to do the same thing for the next equation, which is just as simple. And you do so, and you get negative 2.5. And you know, we could skip this procedure, but I actually don't know the solution. So let's take a look at what this gives us. Minus 4 times negative 2.5 minus 41. There you go. Works out well. That one works as well. So this is a official solution. The next one, 1 and 6, much easier. So you're going to have 6 times 1 minus 1 minus 6 equals negative 1. So it's 5 minus 6. This works out well. And the last one is 4 times 1 minus 4 times 1, right, this is squared, minus 6 equals negative 6. This will cancel, so you're going to be negative 6 equals negative 6. Game, set, and match. So, there we have it. That's basically it. So it's actually a pretty straightforward section. We have all the tools necessary, or all the tools have already been taught leading up to this section. This is more or less an extension of what Math 10 taught you. So now you have sufficient tools to solve many systems of equations that involve 2 equations. Okay. Later on in your career of mathematics, you're going to move on to where you're going to have 3, 4, 5 systems of linear equations, and then you'll talk about matrices, which is great fun. So this will kind of get you ready for that. Okay, so work on the practice problems, do the assignment, and then head over to the Chapter 8 quiz.